Hi, welcome to Integral Calculus, Calculus 2, and Chapter 1, we want to look at antiderivatives. So, what is an antiderivative? Now, we discussed derivative in differential calculus, and the reverse of derivative is what we refer to as antiderivative, as per its name, right? Because when it is anti, it means that it is going against. So the fact that it is antiderivative, it is going against derivative. So whenever you have a function and that function is being differentiated to give you a new function, which we call the antiderivative, that's the derivative now. Now, when you find the antiderivative of that particular one, you go back to the original function. That one makes them to be, it makes it to be a kind of inverse of each other. But let's look at something, right? Now we said a function f, capital F now, is called an antiderivative of the function small f if for every x in the domain of small f, f prime of x is equals to f of x, right? F prime of f of x now is equals to f of x. For f to be an antiderivative, it means that f prime of f of x must be equals to small f of x. Now let's look at something. Why is it that this thing is called an antiderivative? There's a difference between an antiderivative and the antiderivative. Let's look at some examples. What if you had f of x to be equals to x cubed, and then you have f of x to be equals to x cubed plus 5. Then you have f of x to be equals to x cubed minus the root of 8. Then you have f of x to be equals to x cubed minus 97. When this is differentiated, that is, we find f prime of x. When this is differentiated, we get 3x raised to the second power. When this is differentiated, we get 3x raised to the second power. When this is differentiated, we get 3x raised to the second power. This one, 3x raised to the second power. Now, why don't we want to find the there's a derivative, we want to find the antiderivative of these functions, right? We want to find the antiderivative of these functions. So it means that we must be going back to the original function. So to find the antiderivative, which is like getting f of x, antiderivative means to reduce the derivative, right? So want to get rid of this derivative. This is the first derivative. So the process of finding the antiderivative of a particular function, assume that you have a function called x raised to the power n. If f of x is equals to f raised to the power n, it means capital F of x, which is now the antiderivative of this f of x, will be equals to x raised to the power n plus 1 all over n plus 1 plus some arbitrary constant c, and I'm going to explain this one to you shortly. So now, if you are to find the antiderivative of this, right, you have x raised to the power n plus 1. The n here is 2. So you have 3x raised to the power 2 plus 1 all over 2 plus 1. What is this equal to? This will give you, this is 3 down here, so 3 and this 3 go out. You have x raised to the power of 3. What's about this one? You have the same 3x 2 plus 1 all over 2 plus 1. 3 and this cancel. You have x raised to the power 3. The same thing for this one, x to the power 3. The same thing for this one, x to the power 3. Now what do you observe? You observe that after we found the antiderivative of this derivative, we should have actually gotten the original function. But we did not receive the original function because there is a rule for finding the derivative of a constant that provides that the derivative of any number is just equals to 0. So because now it is 0, we cannot find the antiderivative of 0 to give us a function or a number. So based upon that, all of these numbers are not indicated in the antiderivative of these functions. That's the reason why we do not call them the antiderivatives. We call it an antiderivative of a particular function. So whenever we find the antiderivative, we add plus some constant c, plus some constant c, plus some constant c, plus some constant c. So it makes this an antiderivative of the function. This is an antiderivative of this function, this is an antiderivative of this function, this is an antiderivative of this function, and likewise with this one. So you have to get used to that. An antiderivative of a particular function. So using this, our important formula to find an antiderivative of the following functions. Find an antiderivative of each function. So we now have the first one to be, we have f of x is now equals to 3x, then use small f of x, 3x squared plus 2x plus 5. So we solve this first one. The solution. So since we have small f of x, and for convenience sake, we can say capital F of x now for the antiderivative, right? It's just equal to, now each of these we apply the property. So now we have 3x raised to the power 2, this n. So we say plus 1, and then we divide this by the new power 2 plus 1. So for the antiderivative, we are not bringing the power down like we did in derivative. Then we come on this side, we have plus 2, the power here is 1. So it's like saying x raised to the power 1 plus 1 all over 1 plus 1. Plus, now there is an invisible variable here, but it's raised to the 0 power. So just understand that whenever you integrate or you find the antiderivative of a function, it gives you, let's say of a number, it gives you the number times the function or the function variable. So now you have 5x raised to the power 0 plus 1 all over 0 plus 1. So remember we told you whenever you find your antiderivative, add plus some constant c at the end. So now we have this antiderivative down to be 3 and 3 going out, you have x to the third power plus 2 and 2 go out. You got x to the second power plus 5x plus c. So this is an antiderivative of this function. This is an antiderivative of this function.